So again, we're looking at multiplying two rational expressions. The process is the same. The difference is that the factoring and the expressions themselves are becoming more complex. But the process is the same. Our first step is we factor the numerators and denominators of each. So with 2x squared plus 5x minus 12, we want to know what will that factor to. Well, we know a couple things right off the bat. You may not recognize the factorization. We might have to use trial and error, but we know right off the bat we're going to end up with binomials because of the fact that it's a quadratic. Now, the leading coefficient, 2, there is no greatest common factor, first off. 2, 5, and negative 12 share no common factors. And so we do know that the leading coefficient with 2, that only leaves us with the options of 2x and x as our leading terms in our binomials. And then it is kind of a matter of trial and error to figure out the combinations of what factors of 12, so we have 1 and 12, 2 and 6, or 3 and 4, will multiply to negative 12 and end up adding to 5x, considering that we have one term that is 2x, and we have a coefficient of 2 that we have to deal with as well. Now, with a little bit of trial and error, if we look at the possible combinations, as we did when factoring in the past, we'll end up with the factorization 2x minus 3 times x plus 4. So we'll move on to our denominator in our first term, x squared minus 16. Well, that's a difference of squares, x squared minus 4 squared. So that's going to be x minus 4 times x plus 4. Now we'll move on to our second rational expression in our multiplication problem. X squared minus 8x plus 16. We know the leading terms in both are going to be x because we want x squared. We're adding 16 and subtracting 8x. So that tells me right off the bat we're going to have a minus and a minus. And then we want to know what two numbers multiply to 16 but add to negative 8. Well, that's just going to be x minus 4 times x minus 4. And we could have recognized that it was the perfect square trinomial. If we look at 2a or minus 2ab for our middle term, we would end up with minus 8x. But when we have a leading coefficient of 1, sometimes it's just as simple to write it out in the way we normally would. What multiplies to 16 but adds to negative 8. Either way is fine. And then we're left with 2x squared minus 13x plus 15. And similarly, we're probably going to have to use trial and error eventually to determine how this factors. But we can figure out a few things right off the bat. We know that, again, because we have a leading coefficient of 2 on x squared, 2 is a prime number, so we're going to have 2x and x. And then a little bit more revealing, we have plus 15 and minus 13x. So again, since it's multiplying to 15 and adding to negative 13, we know that both of these are going to be minus. Now, once again, we have to use trial and error at this point to determine what the factorization is. But after a little bit of trial and error, we'll find that the factorization of 2x squared minus 13x plus 15 ends up being 2x minus 3 times x minus 5. Now, when we're asked to do these type of problems right now, it makes sense that chances are it's going to be a common factor in the numerator and denominator. So that's an indicator that we want 2x minus 3 as one of the factors, since we have 2x already and we have a 2x minus 3 in the numerator already. So now we simply multiply across the top, multiply across the bottom. We end up with 2x minus 3 times x plus 4 times x minus 4 times x minus 4 over x minus 4 times x plus 4 times 2x minus 3 times x minus 5. And then we'll cancel common factors in the numerator and denominator. So 2x minus 3 and 2x minus 3. We have an x plus 4 and an x plus 4, and we have an x minus 4 and an x minus 4. So that leaves us with, for our solution, x minus 4 over x minus 5. And again, I'm going to note what it shouldn't equal. If we look at what we can't have in our denominator, we'll notice that x can't equal negative 4. X cannot equal 3/2. X cannot equal 4. And x cannot equal 5. And again, you're not being asked to do this with the problem, but I like to be thorough, so I'm going ahead and writing out what x cannot equal, because all of those values would make our denominator in our product 0.